Hello everyone, welcome to Caltex Academy. In case you are new here, I am Julius. Today we are looking at differential calculus, specifically the power rule. If you're a beginner, don't worry, I'm going to explain everything step by step and make you comfortable. And please, before we proceed, please support this channel by giving it thumbs up. Subscribe to the channel to get more notifications for future videos. Share with friends. And without further ado, let's dive right into the video. Alright, before we look at the power rule, let's take a look at derivative from past principle using the definition from this graph. So in this graph, we have a function here, y is equals to x to the power of 2. As we can see here, and we have selected 2 points P with coordinate x and y, and then Q having coordinates of x plus delta x, comma, y plus delta y. So we notice that when this point is dropped down by taking out this line, this straight line, you realize that as the line drops down to this point, the values of delta x and delta y will also reduce by this quantity, and here by this small quantity here. So if this red line reaches at this point as the tangent to this line, y is equals to x squared, and then we will lose delta x and delta y because there will be no change. So with this, let us take a look at the definition from here. As we notice that at this point P, the values or the coordinates here are x and y, and then here it has increased by delta x and delta y respectively. We can let y equals to x to the power of 2 to be equation number 1. So when we call this one equation number 1, and then each side here, the left hand side which says y, will have increased from this point to the other point here by delta y. And then the other side, the right hand side, will have x, will also increase by small increment delta x. But remember, x has been squared, so we're going to square this one, and we have to call this one equation number 2. Now, having written these two equations, we can subtract equation 1 minus equation 2. So we say equation 2 minus equation 1. So let's consider the left hand side of equation 2 with quantities of y plus delta y minus left hand side of equation 1 is having quantity of y. The right hand side of equation 2 is having quantity of x plus delta x to the power of 2 minus the right hand side of equation 1, which is having x squared. So we notice that the left hand side, the quantity y will cancel, and then let's expand the right hand side. So in the left hand side we are left with delta y, while here the first quantity will be x squared, then the middle term will be 2x delta x, and then the last term is delta x squared. So minus our x to the power of 2. Now, having done that, we also notice that we can cancel out x squared, and we rewrite the remaining quantities here from the right hand side, which is delta y from the left hand side, and 2x delta x plus delta x squared. So we can factor out the common factor, which is delta x, and we are going to be having delta x into 2x plus delta x. Now we can divide both sides of this equation by delta x. So on the right hand side we divide by delta x, and then the left hand side we divide also by delta x. And here delta x from the right hand side will cancel from numerator and denominator, and the only quantity we are left with from the right hand side will be 2x plus delta x. Now from our diagram, as we notice, we'll see that if the quantity delta x tends to 0, what happens to the value of the y, delta x and delta y? Like here we have this delta x, if it tends to 0, meaning if this point has come up to here, what happens here is this delta y will not be there and delta x will not be there, meaning it will have turned into dy by dx. So applying that in our assumption here, if delta x tends to 0, then delta y by delta x will turn to dy by dx. Now, having done that, meaning instead of writing delta y by delta x, we are going to write dy by dx will be equivalent to, wherever we get our delta x, it is going to be replaced by this 0 here. So plus 0. And then finally, our dy by dx will be equivalent to 2x. So that is the derivative of the function y is equals to x to the power of 2. And if that's when you look at this function here from the right hand side and the solution we have got here, it can be clearly seen that 2 has multiplied this quantity x here in the solution, and the power here 2 has reduced to power 1. Now in general, if you are given y is equals to x to the power of n, the derivative dy by dx will be equivalent to, we multiply by the power, which is n of that quantity, and we reduce that power by 1 as it has been shown from this example. So what we have here is the power rule we are going to look at. So with this clear picture in mind, we can go ahead and look at example where we're going to use this general conclusion we have got from this working here. So let's look at example that involve power rule. So looking at this question, it says find dy by dx when y is equals to x cubed plus 2x squared minus 3x plus 1. So in our solution, we can copy our question down here where we have x to the power of 3 plus 2 x to the power of 2 minus 3x plus 1. Now applying our power rule that says the derivative or dy by dx is given by, you multiply by the power and then reduce that power by 1 of every of this quantity. So we have 4 terms here. We're going to do the same. And we notice that a derivative of any constant, if you have a as a constant, then the derivative of this constant or dy by dx will be equivalent to 0. So we can go ahead and apply this, and we have our dy y by dx is equivalent to, we multiply by this power and reduce it by 1, so 3 minus 1 is 2. Then when you multiply this 2 by 2, we have 4. Then x, 2 minus 1 is 1. And then we reduce this one here, the power is 1 multiplied by negative 3, we get negative 3. Now when we reduce this 1 by 1, we get 0. Anything to the power 0 is 1, and 1 times this negative 3 is negative 3. So the derivative of this constant is 0, meaning that is our answer for this derivative. So let's move into question number 2. Part B of this part says need to get a derivative. This is part A. So part B is saying get dy by dx of x to the power of 2 minus x to the power of 4, then plus pi. And here we do the same. Dy by dx is equals to, this one turns to 2x, and then minus 4x to the power of 3. And pi is a constant, just like this positive 1. Now meaning it will also vanish to 0, and we shall just simply be left with 2x minus 4x to the power of 3 as our solution, or the derivative of that function y is equals to x cubed plus, x squared minus 4 to the raised to the power of 4 plus pi. Now the last part is y is given by 3 plus x and then plus 2 over x cubed, x squared. Now let's rewrite this function here, the last term, as a linear expression. So we repeat 3 plus x and then now plus. Whenever a quantity change from denominator to numerator, the power will change its sign from positive to negative, or if it is negative, it will change it to positive. So we shall have here 2x raised to the power negative 2, such that it is simple to differentiate. So we can now go ahead and get derivative of this function dy by dx, and since 3 is constant, it will be 0. And then here it will be 1, because when we multiply the power by this, we shall have 1, and then this 1 minus 1 is going to be 0, so anything to the power 0 is going to be 1. So 1 times the 1 we have multiplied with is going to be just 1. Now plus, here our power is negative 2, so I'm going to multiply negative 2 by this quantity, and this quantity has 2 in front of it, and we have our x negative 2, but according to power rule we also drop this by 1. So let's go ahead and simplify our work on dy by dx is going to be equivalent to 1, and this one is going to be minus 4x to the power of negative 3. So we can rewrite this one back in this form, and finally our derivative dy by dx is equals to 1 minus 4 over x raised to power 3. So thank you for supporting this channel by watching this video. Please, I encourage you to subscribe to this channel, share this video with friends, and then see you in the next video. Thank you.